Hi everybody, Josh Byerly here inside Mission Control. I'm joined by Tara Rutley, the Associate Program Scientist for the International Space Station. She actually just got back from Wallops. She's been traveling this week. She saw, I guess, were you there for the launch?
I missed the launch.
Missed the launch, but you were there for the news conference, which of course probably not as much fun, but that's okay.
It's always fun.
So let's talk about Cygnus. It's on its way to the space station. It'll be there this weekend. It's carrying just tons of science for the crew, a lot of student experiments. Talk a little bit about what's on board.
Oh boy, we have just about every kind of discipline on board. So we have a big deal about this launch is that we have a lot of national laboratory payloads. So the national lab is managed by CASIS. So this is a big one for CASIS because it's the first launch that has the largest amount of CASIS selected science on it. So what that means is it's going to enable a lot of research that's going to be focused on Earth benefits, such as looking at how ants behave in space. That's an educational Earth benefit.
Yeah.
There's
the habitat right there.
There you go.
Yeah.
We have flown other creatures to station, so to speak. What we're interested in with the ants is looking at how their movement behavior changes in different patterns in a microgravity environment. And we don't know how they're going to behave. We've never looked at this before, and it's actually going to be performed on orbit. And at the same time, there'll be cameras watching these ants, and that imagery and video will be beamed down to students on the ground. And the students will have their own education experiments with the ants set up in different classrooms all around the country, following the movement of the ants, predicting what they might do, thinking and learning about ant behavior, and just probing the minds of the students as scientists and get them asking the important questions. At the same time, it's really fun because they're getting real on-orbit imagery, and ants are kind of cool to learn about anyway.
I remember we flew some spiders back a few years ago, and I think one of the things that amazed me was that, here's this small insect that adapted extremely quickly to being up in space, and there's lessons to be learned from that, right?
Yeah, it did. Yeah, the lessons to be learned about adaptation apply to every living organism that flies in microgravity. We're all creatures of the gravity environment. So we humans, astronauts, we go up there, we adapt, we come home, we have to readapt again to Earth. We saw it with the butterflies when they were learning to fly. First it was kind of tough for them, then they got the hang of it on orbit. We learned it with the spiders, especially the ones that have to jump after their food. Yeah, because when they got home, we saw videos of the spiders jumping and landing on their backs because they weren't used to jumping in on Earth anymore, right? So they figured it out eventually, and they were able to jump normally again. But every creature goes through a readaptation period, which is why the space station is important, especially for exploration beyond low Earth orbit.
Yeah, we talk a lot about the space station inspires students a lot, and the space station is critically important for science. I think one of the cool things about these recent flights that we've had with Cygnus and even the SpaceX flights, that there's a lot of student activity on board. We talked about it before. There's 23 schools participating, close to 9,000 students. But they're doing real science. Like, these aren't just fun experiments. I mean, they are fun, but they're real science that they're actually looking at. Talk about that.
So there are several investigations as part of the Student Space Flight Exploration Program, where that's through the National Center for Earth and Space Science Education, NCESSE.org. And 23 different investigations ranging from bacterial growth to chemical decomposition to all sorts of things, and they go up in these tiny little mix sticks. And when they're on orbit, they're activated. When they come home, the students will receive those samples back and look at the results of their proposals or their hypotheses. And in fact, these students, I think over 8,000 students are represented on the ground by just these 23 payloads, and there were thousands. There was about 2,000 proposals that were submitted. So it was highly competitive, and these proposals had to go from beginning to end. Why do you think my science counts? What's important? What are we going to learn? What's unique about microgravity? And then these guys are going to have to come back in the summer and talk on stage in DC at the Smithsonian about their results. So we're talking fifth graders, 5th through 12. I never did such a thing when I was a fifth grader.
I don't think I was doing that.
Yeah. So the opportunities that are coming through Space Station for students and they're ongoing, just tremendous.
So talk about, the news came out this week that the administration's proposed the station to be extended to 2024, things like that. Do you think that that's a good thing, that it'll give us more chances to kind of see the real benefits of this? I mean, science is not fast, right? It takes a while to kind of get these things up there, study it, and what do you think that will allow us to do in terms of just the benefits of seeing things here on Earth?
Oh man, first of all, what it's going to do now for us at this very minute is allow us to reach out to researchers to tell them you have ample time to do the research you
Right.
want to do. It's not just going to end in 2020. Because you said science takes time. Scientists want to know how can we replicate what we're doing and do it over and over again to make sure that what we're going to publish is a real benefit to Earth or space.
Yeah.
So yeah, the 2024 extension is going to give us increased science portfolios, increased numbers, but also time to get the benefits and communicate to the public what the benefits are. And as you can, science, you build on science, right? So you get a basic discovery, you build and you build and you build. And in the end, what you get is something that you hope is applicable to Earth or space. So 2024 is going to be really exciting. We've seen it all ramp up so far. It's just going to get even better.
Yeah. So last question for you. I always ask this to everybody. Favorite experiment on board? Maybe not right now, but just in everything you've ever worked on, what's your favorite?
I fluctuate.
You talk about colloids a lot, which took me forever to understand it. But
colloids. The colloids are cool. Colloids, they're not my favorite, but they're cool. They allow us to investigate the behavior of tiny little particles in a mixture of liquids, such as milk. And believe it or not, guys, there's behavior that happens in your milk that you're oblivious to as you drink it every day.
Probably want to be.
You might, but when you're pouring your fabric softener in, you want to know that what you're using is stable and good, right?
Yeah.
And in that mix is colloids. And so we look at investigations of colloids on the space station because we want to know how those tiny little particles really do behave. Because if we can figure it out and manipulate them, what you get is an end product that is optimized for how we ever use it, whether it's putting it in our clothes or drinking it, right? So that's a cool one. My favorite right now, though, is the AMS, looking for dark matter and dark energy.
The secrets of the universe.
Secrets of the
Small
universe.
task.
Yeah,
Small task.
Everybody wants to know. Small task, but it's the coolest.
Thanks, Tara. Appreciate it. If you want to learn more about the Orbital Sciences Cygnus and what's on board, just log on to nasa.gov/orbital. And of course, we always invite you to go to nasa.gov/station. Look on the left-hand side of the page, you'll see a research and technology link there. Just click on that, and you can actually look up every experiment that the crew is actually working on, either by expedition or by alphabetical order. So thanks again, Tara.
You're very welcome.